ISC Class 12 Maths Tutorial. Today's topic is logarithmic differentiation. Before we start, आइए आपको एक शायर की दो लाइन सुनाता हूँ. शायर कहता है, उसको कोई गम नहीं है जिसका घर पत्थर का है. उसको कोई गम नहीं है जिसका घर पत्थर का है. क्या करेगा तेज तूफान बामुदर पत्थर का है. बामुदर रूफ एंड डोर्स, छत और चौखट, दरवाजे. क्या करेगा तेज तूफान बामुदर पत्थर का है. ऐसे इंसान से कभी उम्मीद क्या रखे कोई. ऐसे इंसान से कभी उम्मीद क्या रखे कोई. देखने में आदमी है दिल मगर पत्थर का है. देखने में आदमी है दिल मगर पत्थर का है. उनसे उम्मीदे वफा रखना भी नैयर है फजूल. उनसे उम्मीदे वफा रखना भी नैयर है फजूल. बेमुरव्वत सबके सब हैं, बेमुरव्वत सबके सब हैं और नगर पत्थर का है. बेमुरव्वत सबके सब हैं और नगर पत्थर का है. थैंक यू. We are going to solve questions where first we will be taking log on both the sides. Now the important is, from student's point of view, the question arises, why should we take log on both the sides? Why not without taking log on both the sides? Or when should we take log on both the sides? Alright? So the answer to this question is, when you have function like this, y is equal to fx, y is equal to fx, or y is equal to ux whole raised to the power vx. If your function is y is equal to fx, or especially when you have a function y is equal to ux whole raised to the power vx, that means variable, please understand, this is important, variable raised to the power variable, x raised to the power x, sin x raised to the power cos x, sin x raised to the power tan x, variable raised to the power variable. Here you have to take log on both the sides. Alright. And as far as this first one is concerned, y is equal to fx. So when you have a function fx, like u into v, or u upon v, uv, or u upon v, and if it is complicated, then it is easier to take log on both the sides and then you differentiate. This is easier. In some cases, you have to take log, otherwise it will be very, very difficult. In some cases, you can do without taking log on both the sides when you have such functions, uv or u upon v. I'm not talking about this. Here you have to take log. When you have uv product or u upon v, then and if the expression, if the function is complicated, then it is better to take log on both the sides and then you differentiate. Because we are taking log on both the sides and then we are differentiating, that's why we call this logarithmic differentiation. Because we are taking log on both the sides and then we are differentiating, so we call it logarithmic differentiation. Once again listen, if you have UV form or U upon V form, and if the function is very simple, then you may take log, you may not take log. But if you take log on both the sides, the expression becomes very simple, and it's very easy to differentiate as compared to it's very easy to differentiate by taking log on both the sides as compared to differentiating the function itself, without taking log. Alright? So, now let's do some questions. The first question is, I told you may take log or you may not take. For example, in this exercise, this is ISC mathematics. In this book, the first question is x square plus 2 whole raised to the power 3 into 1 minus x cube whole raised to the power 4. We are going to take log on both the sides, but if you don't take log, then also you will get the answer. It's not very difficult. Alright, though not very easy also, but not very difficult. So without taking log on both the sides also you can get the answer of this question, but the form may be different. And if you are taking log, then it will become very easy. And you don't have to simplify. Further, once you take log on both the sides, you differentiate, and then you get 1 upon something minus or plus 1 upon something, and then you get this side. For example, let me write question, then you will understand. Suppose y is equal to, the question is y is equal to, suppose y is equal to x square plus 2 whole raised to the power 3, whole raised to the power 3, and then we have 1 minus, and then we have 1 minus x3, x raised to the power 3, and then whole raised to the power 4. Alright, this is your function. Not very easy, not very complicated. So this you can differentiate directly using the formula u into v, first function into derivative of second plus second function into derivative of first, and then you simplify. Fine. But if you take log on both the sides, then it becomes very easy, much easier than without taking log. Because in that case, if you take log on both the sides, then you write log y is equal to log m into n formula, log m plus log n, and then this 3 will come out. So you get log y is equal to 3 log x square plus 2 plus 4 log 1 minus x cube. And then one more step, you differentiate, because you know that ddx of log x is 1 upon x. And of course, chain rule you have to apply, and then you get the answer. Alright. So I hope now I answered the question when to take log on both the sides and why to take log on both the sides, because this is an important question. Students are not clear. They have question, sir, why are we taking log on both the sides? Sir, when should we take log on both the sides? So I answered your question. In this case, if you have variable raised to the power variable, then you have to take log on both the sides. And there is like x raised to the power x, sin x raised to the power x, sin x raised to the power tan x. In that case, you have to take log on both the sides. Alright? Okay. So this is one question I can do, but I'm going to do first another question. That question I have taken. This question I'm going to do in this textbook. This is fourth question. In that textbook, this is fourth question. This is okay, no? You can do it? As homework you do. I'm giving you hint. Okay, let me. Taking log on both the sides we get. You please write down taking log on both the sides we get. Fine. Taking log on both the sides we get. Okay, let me solve it. Question number 1. Taking log on both the sides we get. You please write down. Taking log on both the sides we get. Taking log on both the sides we get. So if you take log, then see log y is equal to log y is equal to log, and this as it is I am writing. I am not applying any formula, and only I am writing the operator log on both sides. So log, this is x squared plus 2 x squared plus 2 whole raised to the power 3, and then 1 minus x cube whole raised to the power 4. I've taken log on both the sides. Now here you apply the formula that we have learned in class 9. Log m into n is equal to log m plus log n. Do you remember? Log m into n. This is together like this. See. This is like this. Together. Alright? This you can call as m. This you can call as n. Right? M. So log mn formula we learnt in class 9. Log m into n is equal to log m plus log n. Fine. So then we can write down. We can write down this. So log y is equal to log y is equal to log m plus log n. Log x square plus 2 x square plus 2 whole raised to the power 3, and then plus log 1 minus x cube whole raised to the power 4. We applied the formula log m into n is equal to log m plus log n. You can write down here. The formula that you are using, you can write down here. For your understanding point of view also, you can write down formula here. Log mn. We are using the formula log mn is equal to log m plus log n. Alright? Fine. After that, again one more formula we are going to use, and that is log m raised to the power n. Log m raised to the power n is n log m. So we can write down this is equal to n means 3. Alright? N log m. M means x square plus 2. Fine. N log m, and here also plus 4 log 1 minus x cube. Fine. The formula used, you can write down here. The formula that we are using is log m raised to the power n is equal to n log m. Fine, we have studied this in class 9. Alright, so this is log y is equal to, log y is equal to, log y is equal to. Now we differentiate, so easy, so simple. On differentiating both sides with respect to x we get. Let's write down everything. Differentiating both sides with respect to x we get. Differentiating, write down please here. Differentiating both sides with respect to x. Differentiating both sides with respect to x we get. We get. Now, ddx, differentiating both sides with respect to x. So ddx, right? Please understand. ddx of log y. ddx. ddx of log y is equal to 3 as it is, because 3 is a constant, and ddx of log dx of log x square plus 2. X square plus 2 and plus 4 ddx of 1 minus x cube. 1 minus x cube. Fine. I have only written ddx. I didn't do anything. ddx. 3 aside. We are keeping aside. 4 we are keeping aside. Now we are going to differentiate. So now we differentiate. All these steps are very simple. I am writing all these steps so that you understand. Because this is the starting, the first question I am doing, so you should understand. Once you understand, you can do any number of questions on your own. Understanding is important. The concept is important. Okay, so after this we can write down. Now see, that's now I'm not writing, because then the number of steps is being more. Actually, it is in y, the function is in y, and we are going to differentiate with respect to x, which we cannot. So we should write down dy of log y into dy upon dx. So when we write down dy of log y, that becomes 1 upon y and dy upon dx. Alright, so please remember, so 1 up dy of log y, 1 upon y, dy upon dx. 1 upon y dy upon dx into dy upon dx. One upon y dy upon dx is equal to 3 as it is, and d dx of log x, suppose this is x, chain rule, chain rule, please remember chain rule. Suppose this is x, which is not, but we are supposing, imagine, chain rule. So d dx of log x is 1 upon x, alright, so into 1 upon x, x means x square plus 2, alright, x square plus 2, fine. Because it is not x, we are supposing, imagining this as x, so we once again differentiate it, right, chain rule. So when we differentiate that, I am not going to write down. So once again we have to differentiate this x square plus 2. So the derivative of x square will be 2x and that of 2 will be 0. So ultimately 2x, we are left with 2x into 2x. Is that fine? Into 2x. Okay. Plus 4 d dx of again x, which is not, suppose this is x, so d dx of 1 minus, sorry, here there should be log, no? Log, here there should be log 1 minus d dx of log (1 minus x cube). That log 1 minus x cube, yeah, plus 4 log 1 minus plus 4 log 1 minus x cube. Okay, now this you take as x. Alright, so d dx of log x is 1 upon x, 1 over x, x means 1 minus x cube, fine, 1 minus x cube, but it is not x, it is 1 minus x cube, so we once again differentiate it. That's the chain rule. When we differentiate, derivative of 1 is 0 and that of x cube is 3x square with minus sign, so minus 3x square into minus 3x square, fine. Is this okay? It's done. d dx of log x is 1 upon x and derivative of this is 2x. d dx of log x is 1 upon x and derivative of this is minus 3x square. Okay, that gives you, this is equal to 3 to the 6x. So you get 6x upon x square plus 2 and minus 3 4s are 12, 12x square, 12x square upon 1 minus x cube. Is that fine? Now y will come this side, dy upon dx is equal to y into this much, therefore dy upon dx, therefore dy upon dx is equal to y, and in bracket this whole thing. In bracket this one, 6x upon x square plus 2 minus 12x square upon 1 minus x cube. Right? This is, now put the value of y and that will be your answer. Put the value of y in the beginning of y is equal to, we suppose y is equal to the function itself, that is y. So y is, please write down y is x square plus 2 whole raised to power 3, x square plus 2 x square plus 2 whole raised to the power 3 and 1 minus x cube whole raised to the power 4. This is the value of y, and this as it is. 6x upon 6x upon x square plus 2 and minus 12x square upon 1 minus x cube. This is the answer. Now, if you see the answer in the textbook, this is the answer. If you see the answer in the textbook, the answer is this. The answer is 6x in bracket x square plus 2 whole square, in another bracket 1 minus x square whole raised to power 3, and then third bracket 1 minus 4x minus 3x cube. But ours is different. Both are same. The form is different. If you simplify this, you will get that. Actually, the first question they have done without taking logarithm. So if you solve this question without taking logarithm, like first function into derivative of the second function plus second function into derivative of the first function, then directly you will get this answer, same answer, which is given in the textbook. Alright, they have not taken logarithm. If you are taking logarithm, log on both the sides, then you are getting this, and you leave here only. After differentiating the log term, you don't have to simplify in general. So this is your answer. If you want the same answer, what is given in this textbook, then you have to simplify. Take the LCM, this into this is the LCM. You know, here also x square plus 2 whole cube. Here also you will get x square plus 2, 1 x square plus 2, 1 x square plus 2 will get cancelled, and then you will get x square plus 2 whole square. One factor you are getting. Then 1 minus x cube here and 1 minus x cube whole raised to power 4. So 1 minus x cube and 1 minus x cube. One gets cancelled and 1 minus x cube whole raised to power 3. The other factor, 1 minus x square whole raised to power 3, the other factor also you are getting. And for the third factor, when you simplify this inside, this into this, and you know how to simplify by taking LCM, or you may call it cross multiplication, then you will get 1 minus 4x minus 3x square. You will get it. I have done it. Because I don't have time here, otherwise I would have shown it to you. So when you simplify this, you will get the same answer. So got it understood? The reason we are not getting the same answer is they have solved the question, the first question, not all the questions, only the first question, without taking logarithm. We are doing it by taking logarithm, because taking logarithm, if we take logarithm, the expressions are simpler and it's very easy to differentiate them. Fine. So the forms are different, but the answer is same. And this is the right answer. Absolutely correct answer. There is no doubt at all. Yeah, absolutely correct. You have to leave here only. If you want the same answer, then you simplify, and definitely you will get 100% you will get the same answer what is given in the textbook. Fine. And the book you can see, ISC Mathematics, book 2 for class 12. You can check. Fine. Is this clear? I hope everything is very, very clear. I wanted to do 2-3 questions, but then I think I should stop now. So once again I am telling you, if you have, so here even without taking log on both the sides, we can differentiate it, because this is not very difficult. But if you have complicated expressions in the form of u into v or in the form of u upon v, then you have to take log on both the sides. Y is equal to this, and then log on both the sides, and then you can do like this. And if you have ux whole raised to the power vx, I mean function raised to the power function, or variable raised to the power variable, then you have to take log on both the sides, and then you should differentiate. Is that fine? Clear? Now do practice. Lots of practice. Practice is very, very important. The more you do practice, the easier it is going to be. Always I tell you this. Alright, maths means practice, a lot of practice. Okay, thanks for watching this lesson. Thank you so much. Thanks.